Hello, I welcome you to Let's Learn. I'm Aaron. Today we'll be starting with approximating and running of decimal numbers to a given number of place value. So approximating. Rounding. Okay, we are going to be starting with rounding of numbers to their different places. So with this, let's pick a number. So we have 987.6456. We can run numbers to their nearest 10, 100, and that of 1,000. With this, we have some parts being the first decimal places, second decimal places, third, and that of the fourth. So we have this one as our first DP, decimal place. The 4, second DP. This, the 5, as our third DP, and the 6 as a fourth DP. So if you are asked to round this number into the first decimal place, so I first decimal place, our answer is going to be, since this is the first decimal place, we are going to ignore the rest. Ignoring the rest, we have to see the immediate number after the decimal place that we are running it to. So if it is 5 or more, we carry out a 1 to the decimal place at which we are running it to. So in case this was 5, we would have changed this 5 into 1, adding it to this 6. To get a 7, but since it's not up to 5, we maintain it like that. So we have the first decimal place to be 987.6 to the II. Second decimal place, have a second decimal place to be 4. So 987.64. We have the number to the immediate left of the 4 as 5. We have to change this into 1. So therefore, we are rounding it. We change the 5 into 1, adding it to the 4, making it 5. So we have our second decimal place, changing it into the second decimal place, we have 987.65. So as we do to the subsequent ones. Now we are going to be talking about rounding them to the nearest 10, 100, and 1,000. So rounding to the nearest. Sorry. 100 and 1,000. Using our first example, That's 987.6456. Since we count it this way for the tens, the hundreds, the thousands, and almost, we count it this way, but we don't start from 1, since there is no 1. We start from the 10th, the 100th, and the 1000th. So let's change this into the 10th, the 100th, and that of the 1000th. We have 10. When you see the TH, it signifies in the decimal place. So we have our 10th going to be 987.6. Since the immediate number to the left is not up to 5, we can add 1 to the 6 to make it 7. We have to the 100, it's going to be 987.64, but the number to the immediate left is 5, so we change it into 1, adding it to the number, the last number, that's 4, making it 5. So we have 987.65 to the 1000. That's 1,000. 10, 100, 1,000. With 1,000, the number to the immediate left is 6. Since it's 6 is 5 or more, we add it, we change it into 1, adding it to the 5 to make it also 6. So we have 987.646. Another number we have 5.3612 to the 10. Just as we did for the first example, we are going to do the same for the second example. So we are going to have 5.3 or 4. Since the number to the immediate left of the 10th is more 5 or more, we add the 1 to the 3, making it 4. To the 100, we have 10th 100. The number to the immediate left is less than 5, hence we maintain it. So 5.36, then 1,000, 1,000. The number to 10th 100, 1,000. The number to the immediate left is less than 5, so we maintain it. So 5.361. The next we're doing is significance figures. We have significant figures. With significant figures, it deals with numbers, but significant figures start with the first non-zero. So you can have a lot of numbers, but if 0 is starting, it starts from the first non-zero. Therefore, we have an example as 0.00035. When you are asked how many significant figures are in here, we have 2 significant figures. So we have 2 significant figures. So with these 2 significant figures, there are zeros in front, but it doesn't matter if it is in the decimal place or not. What we want is the first non-zero. So if we had a 1 here, then all this would have been a significant figure. But since 0 begins it, it's not. So another thing to note is that When a number comes and the 0 is found in the middle, it is also counted as a significant figure. But when the 0 starts the number, it's not counted as part of the significant figure. Therefore, we are going to have an example as 742,396. With this, we can be asked to change this into the fourth significant figure. So with this, we have fourth significant figure, we have third, and we have fifth. Let's see. This is our first, our second, third, fourth, fifth, and sixth. Our fourth is going to be 1, 2, 3, 4. And the number to the immediate left is 9, more than 5. 5 or more, sorry. So we have to approximate it. Change this into 1, adding it to the 3. So we get the fourth significant figure. Changing this, we are going to have 742,300. Since there is a 9 behind it, it's going to be 4, so we round it. 400. Now after we find the position of our fourth significant figure, the numbers behind it all changes into zeros. The numbers behind it all changes into zeros. So with our third significant figure, let's move on. We are going to have 742,000, sorry. That's it. Since it's the third, we count from here. 1, the first, the second, the third. Since the one to the immediate left is not 5 or more, we can add 1 to the 2. So we have 0, 0, and 0. To the fifth, we have 742,000. Now we count. First, second, third, fourth, fifth. This is 5 and more. Since it's 6, we convert it into 1, adding it to the fifth significant figure. So we are going to get 400. Since this is 9, when you add the 1 to it, you are going to get, when you add the 1 to it, you are going to get 10. You carry on the 1 to the 3, making it 4. That's the fifth significant figure. Our last thing we are going to be doing is standard form. Standard form, changing numbers into different form, of which you are going to be seeing the form I'm going to change this into. So with an aid of an example, you have a better understanding of it. So we have our first example as 2,846. With this, if you are asked to change this number into the standard form, what you do is you have to move the decimal. When you have a normal number like this, the decimal place is here. It's behind the last digit. So we have to move the decimal place to the first number. That's a non-zero. So between the first number and the second number can be 0, but the first number shouldn't be 0. So if you are asked to move this, you are going to move the point from this point. So 1, 2, 3. It's very necessary to count the number of rounds to do, so you can have a better answer. So with this, remove the point to the first and the second digit, between the first and the second digit. So we are going to have 2.846. Now, when moving the point, we are supposed to count, just as we did. 1, 2, 3. So we multiply it by 10 raised to the power 3. If this number is multiplied by 1,000, we are going to get our initial number. The number of rounds removed determines the exponent on the 10. The 10 is a constant, so the number of rounds you move determines the exponent of the 10. And also, the exponent can either be positive or negative. With it being positive, it means we moved the round to the left. That's the only way the exponent can be positive. So now let's have another example as example 2. 0.0048. Changing it into the standard form. For this, we move it to the first non-zero. So what's our first non-zero here? We can't take this because it begins with a 0. No, so it has to be between the first whole number and that of the second. So remove the point. Now remove it to the right. So 1, 2, 3. So it's going to be 4.8 times 10. I said the 10 is constant. And since now it's moving to the right, it becomes negative. Since I told you when it moves to the left, it's positive, it's vice versa. Therefore, when it moves to the right, it's negative. So we have negative 3. That's how to change numbers into their standard form. We're moving on to addition and subtraction of standard forms. So we have addition and subtraction. Of standard form. So our first example, we are having 2.8 times 10 raised to the power 4 plus 1.6 times 10 raised to the power 4. In solving this, normally what we do is that we group the numbers with the decimals at one point, and we also group the numbers with the exponents at one point. But with this, since the base 10, the 10 has the same exponents, we only pick one and add the numbers to the decimal places. So we are going to have 2.8 plus 1.6 into bracket times 10 raised to the power 4. Since their exponents are the same, so what's 2.8 plus 1.6? So we added 8 plus 6 is going to give us 14. So we have 4 point. The 1 moves to the other side. Therefore, we have 1 plus 1, 2. 2 plus 2, 4. So we have 4.4 times 10 raised to the power 4. Our answer is 4.4 times 10 raised to the power 4. Example 2. We have 2.5, sorry, is the power minus 10 minus 1.6 times 10 raised to the power minus 4. Just as I said for the addition, so as applied to the subtraction. So we group them. That's 2.5 minus 1.6 times 10 raised to the power minus 4. So when we add 2.5 minus 1.6, we are going to get 0.9 times 10 raised to the power minus 4. Since they are having the same exponent, we pick one of them. So our final answer is 0.9 times 10 raised to the power minus 4. But I told you we need it in the standard form, and this is not in the standard form. Hence, you have to also change it. So the first non-zero, that's 9. So remove the decimal place to the right. So we have 9.0 times 10 raised to the power 1 times 10 raised to the power minus 4. When numbers with the same basis have different exponents and they are multiplying, what we do is we add the bases, the exponents, sorry. So we have 9.80 times 10 raised to the power minus 1 plus minus 4. Our final answer given says 9.0 times 10 raised to the power minus 5. Since minus 1 plus minus 4 yields minus 5. Our final example on addition and subtraction of standard form, we have example 3. Okay, 3.6 times 10 raised to the power 2 plus 2.1 times 10. In adding this, of which the bases have different exponents, you can't say you are going to choose one. Hence, we have to convert it into its normal state, solve it, after that convert it back into the standard form. So we convert this into its normal state. Since it's positive, now the points move back to its normal state. That's 1, 2. So we are going to have 360 for the first part, and this has an exponent of 4. Since it has an exponent of 1, of which is not written, it moves 1, so we have 21. Now we add it and now change it back into the standard form after the addition. So now let's add it. We are going to have 3, we are going to have 8, 1. That's 381 for our answer. After getting this answer, now we have to convert it back into the standard form. Now the point is located behind the last number. So we move it to the left. So 1, 2. We are going to get 3.81. We have the constant, that's 10. Raised to the power. How many times did we move our points? We moved it twice. So raised to the power 2. That's our final answer. The last part of it is multiplication and division of standard form. Multiplication and division of standard form. Our first example is we have 9.3 times 10 raised to the power minus 5 times 2 times 10 raised to the power 3. This is multiplication. Just as we did for the addition, we have to group the numbers with the decimal places at one side and the bases with exponents at one side. So we have 9.3. Don't forget, this 2 means 2.0, but it's normally not written. The 0 is normally not written. So we have 2.0 times 9.3 times 2.0, but the 0 is not normally written. So we have times 10 raised to the power minus 5 times 10 raised to the power 3. So we have to multiply this, then now we deal with the ones here. So the first thing we do is we multiply them. 2, 3, 6. 2, 9, 18. So we are done with the ones with points. Moving next to the ones without points. That's the ones with the exponents. As I told you, I said when numbers have the same basis and they are multiplying, what do we do to their exponent? We add them. That's one we have to know. Numbers with the same basis, having different multiplying, we add the exponent. So we have 10 raised to the power minus 5 plus 3. So we are going to get 18.6 times 10 raised to the power minus 3 minus 5 plus 2 plus 3 gives us minus 2. That's our answer. Example 2. We have 2.16 10 raised to the power 6 and divided by 5 times 10 raised to the power 2. Just as I said, we group the numbers with points at one side. So we have 2.16 by 5. And also group the other ones to the other side. Sorry, divided by 5. Okay, then we group the other one on the other side. So we have 10 raised to the power 6 divided by 10 raised to the power 2. With this, without the use of calculator solving it, we have to change the decimal part into a whole number. Then after that, we can divide and add the decimal part, the form that we changed it into. So we have to change this one first. So we are going to get 216 times 10 raised to the power minus 2 divided by 5. 10 raised to the power 6 divided by 10 raised to the power 2. So what we do here is we divide the 5 by the 216. Then later on we come back to the 10 raised to the power minus 2. So with this, 5 into 2 is not possible. So 5 into 21, we are going to get 20, that's 4. So with the 4 we have an extension of 1, because 21 minus 20, we are going to get 1. Now we add the 6 to it, having 16. 5 into 16 is 3. We have 15. 16 minus 15 is 1. We bring a point. Now we add a 0 to the 1. 5 into 10 is 2. We have a 10. That means we are able to divide it equally. Now there is 10 raised to the power minus 2 in the presence. So now we deal with this part. Since it's negative, it means it goes to the left. So we have 1, 2, getting 0.432 to bracket. When you are having numbers of the same basis, of which are dividing, you subtract their exponent. So we have 10 raised to the power 6 minus 2. We get 0.432 by 10 raised to the power 4. We have to change this into the standard form. Therefore, the point has to be between the first whole number and that of the second number. So remove it once to the right, making it negative. So we have 4.32 times 10 is the power minus 1 times 10 is the power 4. Now we have numbers with the same basis with different exponents by multiplying. So the law applies here. So times 10 raised to the power minus 1 plus 4. We have 4.32 times 10 raised to the power 3. That's our final answer. Thank you for learning with us. Bye-bye.